Now some of you have said to me, I could do the question because the answers were there, because it was multi-choice. So I went through and I picked and one worked, and then it was fine. But the question was, well, how do you actually do it if you don't get given the answers? What is x plus, hold on, let me read the exact wording, sorry. Alright, then I want to know what f of x is. Okay, what's f of x? Okay. Now, to try and understand this question, it would have been better actually if it was an equivalent sign, but it doesn't really matter. You've got to try and wrap your head around, what's the question even asking? Okay, so to try and explain that, let me try and draw your mind back to this, which you think has nothing to do with this question, but actually has everything to do with this question. Okay? What is this? No, seriously, what is it? This is trig. More specifically, it's auxiliary angle, isn't it? Okay. Now, this is actually very interesting. You take two wave functions, oscillating things, right? And you add them together, no matter what their amplitudes are, you can put them together and get another wave function. But how can you do that, apart from actually drawing it and doing addition of ordinates? How did we prove it? Well, you just look at this left-hand side, right? And you know there's expansions. We learn trig expansions, and when you expand this guy, you will get something very similar to this, but the coefficients will be a little different, won't they? Instead of being a's and b's, they'll be in terms of r's and alphas. Okay. So the idea I'm trying to get across to you, though, is what you have on both sides of the equivalence is the same kind of function, just sort of dressed up in different clothes. Okay. Now that's what you have here. Okay. Now you're used to saying, oh, f of x equals x squared plus 2. It's a function, it's in terms of x. Okay? But they're telling you this function is not actually in terms of x, it's in terms of x plus 2. You're like, what does that even mean? Okay, well, let's think about this. If I gave you a function in terms of, say, theta, okay, I could have written this. Sine 2 theta plus cos theta. There you go. There's a function in terms of theta. Is that okay? I can give you a function in terms of y. I could write e to the y plus log y. That's a function in terms of y. Okay. So what might a function look like if it was in terms of x plus 2 as a thing, right? Well, you can think of some functions in terms of x plus 2. You know, this would be a function in terms of x plus 2. Log of x plus 2 plus the absolute value of x plus 2. I don't even know what that looks like. But it looks like something. And the point is that the variable I'm interested in is x plus 2. I stick it in all these places, you get a function. Okay? But hold on, they're telling me this function of x plus 2 is not just going to be anything. Okay? You actually are very, very limited in the kinds of candidates you can choose. For example, I know whatever f of x is, it's not going to be this. I know it's not, because there's no trig here. Where would this trig go? Where would it disappear? Answer, nowhere. It can't be this either. There are no exponentials or logs or absolute... maybe. Anyway, it's not though, okay? I'm very limited. If what I've got on the right-hand side is a quadratic, just like what I've got on the right-hand side is trig, right? The left-hand side's got to be the same kind of family, just dressed up in different clothes. Okay? You see, this is in terms of x. This is in terms of x plus alpha. What might this thing look like? Well, it's a quadratic in x plus 2. Just like this is a quadratic in x. So, I could write a quadratic like this. That's a quadratic in x, isn't it? In fact, that's the only kind of quadratic in x that exists for different values of a, b, and c, right? So what would a quadratic in x plus 2 look like? It would look like this, right? That's not just a quadratic in x plus 2, that's every quadratic in x plus 2, depending on what a, b, and c are. Okay? Now, I don't want any one, I want the specific one that ends up looking like this. Okay? So, how did we work this thing out? Well, you use a trig expansion, and then you compare both sides, right? I'm going to do exactly the same thing here. Let's just get rid of all of this other rubbish that I don't need. What am I going to do? Well, I'm going to use an expansion, but it's not very fancy. It doesn't have a cool name like the trig expansion. It's just the expansion of x plus 2 all squared. What is x plus 2 all squared? That's x squared plus 4x plus 4. Whoa, crazy identities here, okay? What's the rest of this? This is bx plus 2b plus c. That's apparently all equal to x squared plus 2. That's what they're telling you. That's what the first line says, okay? Now, I can't quite compare coefficients like I have here yet. I need to do a little more work. I'm going to get ax squared, 4ax, 4a, and then all of this trailing stuff. Okay, right now have a look at it with me, okay? For instance, have a look at that x squared term, okay? Now, what's the coefficient of x squared over here? It's 1, right? Now, where could that 1 possibly come from on the left-hand side? And there's nowhere else to look except here. There are no other x squared terms, right? There are ax squareds over there, and there is, oh, I'm leaking. There's 1 here, okay? Hang on, tissue. So a and 1 have to be the same. There's nowhere else the x squared terms can come from. A must be 1. Okay, if you want, you can say by comparison of coefficients, which is exactly what you do when you're doing auxiliary angle from scratch, right? You expand this guy and then you say by comparison of coefficients, r cos alpha equals blah, 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 blah. Okay? All right, we got A. So let's keep going. We'll go up here. If I know A is 1, I've got x squared plus 4x plus 4 plus bx plus 2b plus c. Okay, I've already accounted for the x squared terms. How many x terms are there on the right-hand side? There are none. But I have some floating around here, right? So that must mean that here's 1 and here's the other. Whatever they are, they must leave me with 0 lots of x, right? Because that's what I end up with, right? So here, let me make it a little more obvious to you by factorizing. There's my x squared hanging out the front. How many lots of x do I have? B plus 4 lots. Right? No, because I've already dealt with A. I know what A is, right? And of course you need to, because otherwise you've just got too many variables flying around. Okay? So B plus 4x plus, what do I have left here? 2b plus c plus 4. Okay, you can see where it's going now, can't you? Okay, b plus 4 by comparison of coefficients must be 0. So there's your value for b. Okay, one more time so we can finish it off. X squared, where was I? I was here, wasn't I? I've actually already dealt with all the x's, so I'm just going to worry about these guys here. Plus 2 times negative 4, that's b, plus c plus 4. That's equivalent to x squared plus 2. Okay? So all of these guys must equal 2 because that's the constant terms. There's nowhere else where they can come from. Okay? So that's actually c minus 4 equals 2. Yeah? Okay? So now I know what my a and b and c are. I can say what f of x is. F of x, right? There's f of x plus 2. There. Right? Now I replace all the x plus 2's with x's. A is 1, b is minus 4, and c was 6.